The very last thing we have to talk about in Chapter 9 is how to factor some things that look a little weird. So by the end of this lesson, that's what you should be able to do. The things are called difference of two squares, two variables in one equation, and then some special cases. So weird case number 1. What if you have some variables in here, but you have variables on both sides? You are going to approach the problem exactly the same way. The first thing you do is look for a GCF. There is nothing that all of these things have in common, so then you move to step 2. You want to factor by grouping. So just like before, you want to set yourself up with numbers. You need two numbers. They still have to add to make the number in the middle, which is 11, and they got to multiply to make the first and the last term together. So 1 times 24 is 24, and then you rack your brain. The numbers that make 24 are 24 and 1, 12 and 2, 8 and 3, and 6 and 4. And 8 and 3 will add up to 11. So those are the numbers I'm going to use to break this middle term up. Now the important thing to remember is this is 11xy. So when I go to break this up, I'm going to have 8xy plus 3xy. You got to keep them the same so that when you combine them again, you could end up with that. So this part is still on there, and then this part. So now, factor by grouping, because we got 4 things. These guys have an x in common, so I end up with x plus 8y. And these guys both have a 3 and a y. And I need an x, and then I need an 8 to make it 24, and one more y to make it y squared. And just like all the other things that we've done, these end up being the same, so we can factor that out. And what we're left with is x plus 3y. And we're done. It's important to check this when we're done and make sure it makes sense. So we start with x's and x's, so that's where the x squared comes from. We'd multiply these back things together, so that's where the y squared comes from. And then when we do these guys multiplied together, that gives us the 11xy. I'll leave that one for you to try on your own. So now the next case is something called the difference of two squares. So difference, remember, means subtraction. And two squares means something that's squared, like x squared, y squared, or even a number like 4, because 4 is really 2 squared, or 16 is really 4 squared, or 64 is really 8 squared. Those are all squares. So when you have something like this, it's important to see that there is no middle term here. So when we break stuff up, we want it to add to 0. We want it to go away. So the steps are exactly the same. Look for a greatest common factor. They don't have anything. So then you start racking your brain. You want two numbers. They have to add to make 0 because there's no middle term to break up here. And they got to multiply to make a negative 36. These numbers are positive 6 and negative 6. Those add to make 0 and multiply to make negative 36. So just like all the other things that we were doing, you can break this up, and then you can factor by grouping. And this is why there's no middle term. You have a positive and a negative of the same thing. These would cross off and we'd get 0. So when we factor by grouping, remember you're looking at these guys. They both have an x, and then you have x minus 6. These guys both have a 6, and you're left with x minus 6. So again, the x minus 6's are the same, and we get x plus 6. Let's do one like C. So we notice that there's no middle term, so we want two numbers that add to make 0, and they got to multiply to make, remember you got to multiply these together. 4 times 49 is 196. So the awesome thing about this is because we know they have to add to 0, they need to be the same number. One just has to be positive and one has to be negative. So we can figure this out by just quickly taking the square root of 196. And when you do that, you end up with 14. So that's what we're going to split up this into. Negative 14w plus 14w minus 49. And hopefully the factoring by grouping is getting a little easier. And recognizing what things have in common is getting a little easier as well. I can pull out a 7 here, so I'm left with 2w minus 7. I have two 2w minus 7s, and then a 2w plus 7. Now I want you to look at both of these answers that we got. These answers are special. Remember, these are weird cases of things. These answers look almost identical, except one has a positive and one has a negative. One has a positive, one has a negative. There is a much quicker and much easier way to do these problems because they're so special. If you have a difference of two squares, so two numbers that are squares with subtraction in between, you know that the product of the factors has to be whatever this number is plus whatever the other number is, and then whatever this number is minus whatever the other number is. So they give you one like this, x squared minus 81. X squared is really x squared. 81 is really 9 squared. So x and 9 are going to be my two factors. One you put a plus in between, the other you put a minus in between. So same thing with this next one. 16x squared is really 4x squared, and 49 is really 7 squared. So 4x and 7 are going to be the numbers that you put in here. One has to have a plus, one has to have a minus. So if we go back and try this last one that we left alone here, let's do it up here. M squared minus 100. M squared is really just M squared, and 100 is 10 squared. So I know that this factored is M plus 10 times M minus 10. And remember, you can double distribute this out and double check it. So if you notice the difference of squares, way easier to do it this way than to do it the other way. But know that it's not wrong to do it with the factoring by grouping. It just takes some more work. So weird case number 3, perfect square trinomials. So let's just factor this one. When I have something like this, look for a GCF. When there isn't anything, we need two numbers that add to make 8. They got to multiply to make 16. Those two numbers are 4 and 4, exactly the same. So when we go to break this up, and then we factor by grouping, something weird happens. These guys have a 4. X plus 4, and then what's left over is x plus 4. And remember, we tend to write this as x plus 4 all squared because this is a perfect square trinomial. So this one over here, we can approach it the exact same way, or we can take a look at what we did back here and try to come up with a pattern. So this number here and this number here give us the same number. When that happens, you are always going to end up with that number as your only factor. So when we look at this one, there's no common factor here, so I need two numbers that add to make 36, and they got to multiply to make 4 times 81. And if you type 4 times 81 into your calculator, you get 324. So then we can stop and think about what those two numbers have to be. Because they have to add to make 36, I know they both have to be positive, and these numbers are 18 and 18. So again, we get the same thing just like we got before, and when we go to split it up, we can group these together. We can pull out a 2 and a t, so we're left with 2t plus 9. This one, they both have a 9 in common, and I'm left with 2t plus 9. So I end up with 2t plus 9 twice. So we like to write it like this, 9 squared. So now an easier way to do problems like these are to look at this pattern here. If you have a square on the front and the back, see if what's in the middle is 2 times those two numbers together. So they give you something like this: x squared plus 10x plus 25. X squared is a perfect square because it's x squared. 25 is a perfect square because it's 5 squared. And now you want to see, is 10 the same thing as 2 times x times 5? And it is. So because of that, I know that this has to be x plus 5 all squared. So now if we take another problem, like this one, where it's a little more intense, we can still do the same thing. 4t squared plus 36t plus 81. So I look at this problem and I know 4t squared is a perfect square because it's 2t squared, and 81 is 9 squared. So then I have to double check, is 36 the same as 2 times 2t times 9? You end up with 4 times 9 is 36t. So because of that, I take this part, and that's my factor. So just like before, if you want to, you can memorize this rule, but you can also just do it by grouping, and you will end up with the same exact thing. This last slide here kind of walks you through how to tell if something is a perfect square trinomial. So this one is 4x squared is 2x times 2x, 9 is 3 times 3. If you do 2 times 2x times 3, you get 12x. So that tells me that this factors into 2x plus 3 all squared. Or if you have one like this, it's the same first term and the same last term, but 20 doesn't add up to that. So you're going to end up with different things in here. You're going to end up with 2 different factors, and you will have to factor that one by grouping. So you should be able to factor some weird things. Write down any questions you have, and we can go over them in class. Enjoy your night.